Hello everyone, welcome to my YouTube channel. My name is Nidhi from Sri Venkateshwara College of Engineering, Bangalore. My library ID is 23DS 2064. Basically, I am a first semester student of the Department of Basic Science. Subject is Applied Chemistry for the CSE stream. Topic goes with the corrosion, types of corrosion, and a theory. Corrosion. Corrosion is mainly defined as the natural tendency of a metal to undergo the destruction or dissolution by the chemical or electrochemical reactions. For example, rusting of iron, metal, etc., as you can see in the below pictures. Corrosion may occur either in the dry or an aqueous medium. Mainly, there are two formats of corrosion occurring, that is, dry corrosion and a wet corrosion. Dry corrosion, which is also known as the chemical corrosion. It involves the direct attack of the metal by dry gases, mainly through chemical reactions. It occurs by direct attack of the natural gases such as oxygen, hydrogen, sulfide, halogen, and sulfur dioxide on the metal, forming an oxide layer. These are the example where all these metals are exposed to the atmospheric gases which undergoes the dry corrosion. So next, coming to the wet corrosion, which is also known as the electrochemical corrosion. It involves the reaction in aqueous solution medium. The conducting surface of a metal undergoes an electrochemical reaction with the moisture and oxygen present in the atmosphere. This is the example of wet corrosion. Wet corrosion is also explained on the basis of electrochemical theory. Moving to the electrochemical theory, taking iron as an example. When a metal such as iron is exposed to the corrosive environment, following changes occurs. A large amount of tiny galvanic cells with anodic and cathodic regions are formed. At the anodic region, oxidation reaction takes place and the metal gets converted into its ions, liberating some of its electrons. Therefore, metal gets corroded at the anodic region. At the cathodic region, the reduction reaction takes place. Since the metal cannot be reduced further, metal atoms at the cathodic regions are unaffected by this reaction. At anode, the oxidation reaction takes place in which the metal atoms are converted into their ions, liberating some of the electrons. At cathode, the reaction is based on the nature of the environment. In the absence of oxygen, first, in acidic medium, the liberation of hydrogen takes place here. Second, in the alkaline medium, hydroxide ions are formed with the liberation of hydrogen. In presence of oxygen, in acidic medium, absorption of oxygen takes place. In the alkaline medium, hydroxide ions are formed. Further, the iron ions are combined with the hydroxyl ions to form iron hydroxide on the surface between the anode and the cathode areas. Iron hydroxide further reacts with the oxygen and water, forming the hydrated iron oxide, which is the corrosion product called as the rust. Moving to the types of corrosion. First, differential metal corrosion. This type of corrosion occurs due to the difference in the metal of electrode potential on combining with two different metals. When two different metals are combined with each other, metals which lie high in the electrochemical series acts as the anode and undergoes the corrosion, whereas the metal which lies in the lower electrochemical series acts as a cathode and it's not affected. Example, steel pipe connected to the copper plumbing, lead tin shoulder around copper wires, steel screws in the bronze equipments, etc. The second type is the differential aeration corrosion. When a metal is exposed to the different oxygen or electrolytic concentration, it forms galvanic cells. Here, part of metal which is exposed to the less concentration of oxygen acts as anode and undergoes the corrosion. The other part of metal which is exposed to the high concentration of oxygen acts as a cathode and it is protected. Example, steel water tanks, areas less irradiated and the machines, etc. This was all about my presentation. Thanks for watching. Do like and subscribe the video.